Again, sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host, meteorologist DT from Weather Risk, your commander of chaos from Colonel Confusion. Let's talk about this week in weather. And this is January 22nd, 23rd. I actually made this video, or started to make it last night, so I'm just going to call it the 22nd into the 23rd. And if we take a look at what's going on here, we can see, first I want to go over a couple of different items on this forecast. First, the extreme cold patterns come to an end. No doubt about that. The big northeast winter storm is showing up in the European model on February 3rd, to some degree on the GFS. It's mostly going to be a northern mid-Atlantic, New England type of storm, from what I can see, if it happens. Then we get mild the first half of February, after February 2nd or 3rd, maybe all the way to the 15th or 20th. And then we'll have to talk about maybe a second half to winter, late February, March. So let's get into it. Of course, this here is the website. You can see here. And again, if you wanted to get the different services, the 3-week newsletter, the snow removal forecast, the Mid-Atlantic forecast, I send out several times a week. You just go to the shop page and you just sign up there. You buy your stuff there. And then this here is the grain page, and of course this is the blue sky page here. And now first I wanted to go over the temperatures. This is this morning temperatures, quite impressive as you can see. This is early on Thursday morning at dawn. A lot of single digits, and many areas in the valley were sub-zero as you can see. And again, just the readings were even like places normally milder like DC and Richmond were in the single digits. Very impressive. Extreme cold for this time of year. And again, you can see, look at Ohio, actually temperatures are actually not nearly as cold. So this area in Virginia, Maryland, southern Pennsylvania, New Jersey, Delaware, eastern portions, West Virginia, definitely the coldest right now east of the Mississippi River. But in North Carolina, I mean, it's still pretty darn cold. And with the snow on the ground in the deep south, again, a lot of readings in the teens, which is remarkably cold for this time of year. This here is the recent snow in the Hampton Roads area from the National Weather Service Wakefield. It's a reasonably accurate map, but there are some gaps and mistakes in it, and you'll see higher in a second. This is from National Weather Service. Okay, there were amounts in Chesapeake and Virginia Beach and Norfolk to 4 inches. I posted that before. They did not include them. I don't know why. As you can see, there are no 4-inch snowfall amounts in Norfolk or Virginia Beach or Chesapeake, so I guess they decided to go with the lower amounts because their forecasts were lower. I'm not sure. And you have to be careful with the data, because let me show you what I mean. Now, this is from one of the sites the Weather Service runs, where you can look at the dots for the snowfall amounts. And then when you zoom in, you actually get the actual numbers, but the dots represent ranges. So if you look at New Orleans, you see the blue dots there, which is like 2 to 3, 3 to 4 inches of snow. But if you look at again, you can see that data here, and that's a repeat. It's not a long slide. This here is the actual data I meant to show here. Now, there were reports in New Orleans of people getting up to 8, 10 inches of snow. That's all over the news. So why the data doesn't have those dots in and around New Orleans and Baton Rouge, I don't know. But it's clearly wrong. So as you can see. And then look at Gulfport and Biloxi. They were in the 6 to 8 inch snow band. Not according to this. I don't understand what the problem is. I just don't get it. And here is the snow reports there for the southeastern U.S. And all the way up. And these are fairly accurate. I don't know what the problems on the Gulf Coast. I guess maybe the amount of snow surprised people. And then also you can see the snow amounts don't match along the Carolina coast. You can see the actual data was quite a bit heavier. So again, I'm not exactly sure what the problem is here. There were many areas which received on the Carolina coast more than 4 to 6 inches of snow, but again, I'm not sure how they calculate it, where they get the data from. There are clearly gaps in the data. I'm just saying. Now, this has been the pattern here for most of January, and this is January 19th on the back here. Let me call up a marker so you can see it. Here you have a big trough here, the big ridge in the just off the west coast in Alaska, and the polar vortex coming very far south, and a flat ridge in the southeast. This is a textbook, classic, positive TNH pattern, tropical northern hemisphere. This is what it looks like in the textbooks right here. This is from January, the winter of 2013-14, which was a severely cold winter, if you may recall, just waves and waves of extreme cold and frequent minor to moderate snowstorms. And you can see the pattern is very similar to what we've been seeing. This also occurred in a La Nina when you had a westerly phase QBO, so it seems to be a tendency for the atmosphere to respond to that. Just to show you the difference, I posted this before, but again, I'm going to call it up here. You can see this is the TNA pattern when it's positive. There's your negative anomaly in the Pacific Ocean. You get a ridge on the west coast, a negative anomaly in the southeast, and then your cold air comes down this way, and sometimes it gets stormy. But this is the positive TNH pattern, not PNA, positive tropical hemisphere. Here the ridge is not on the western Canada, but all in the eastern, just off the west coast, in the immediate eastern Pacific. Okay, and you also have a block in north slope of Alaska, which you don't have in the PNA. And then you have the polar vortex is situated very strong and far to the south. So what makes the TNH pattern unusual is that the polar vortex is strong, not weak, but the vortex has come south itself. All right. So what happens is that brings the cold air in. Usually, to get a cold pattern, you want the polar vortex to be weak and fracture. But with the positive TNH pattern, that doesn't happen. The whole polar vortex comes southward, and the cold air gets displaced. Okay? All right. Now let's talk about the MJO here and see what's going to happen in the next couple of weeks. Here's the European model. Oops, let me go bring this front. You can see it. European model here. There's in phase 3. Notice what it does. Barely clips phase 4, then jumps into the neutral circle through February 22nd. Here's the GFS ensemble. You can see phase 3 barely clips into phase 4, then right along neutral zone, then bam, out back into phase 6, and eventually phase 7 by February 22nd. Same general idea. The difference is that the European turns it into neutral circle, the GFS just bumps it along the edge, and you get a little bit of phase 4, 5, and 6 in here. Now the CFS, which has been the hot model late, also is like the European. It drops it straight into the neutral circle, bypassing phase 4, phase 5, and then even to phase 6 by February 20th. So that's a little different here. Now, the reason why this is important is because if you look at phase 4, you get your big and positive anomaly here in southeast Canada, and then you end up getting a strong ridge in phase 5 and 6 on the east coast, and you get a very warm pattern here, even into phase 7. So that's why that's important. If you look at the anomalies, the rainfall biases, phase 3, 4 here on the left-hand side, you can see it gets fairly wet in the Midwest and the Northeast. Phase 5 and then phase 6 is quite wet, everybody, as the pattern begins to shift back towards a colder cycle. But you can see that 5 and 6 get pretty wet in the Midwest here. Well, 4, 5, and 6 really. And about not that wet on the East Coast, mostly the Midwest, the Ohio Valley. Now the temperatures, phase 3 is not bad. That's where you are now. You can still see a generally biased temperatures, and we do for the next week or so. It stays cold. But then phase 4, here comes the temperature anomalies. Phase 5 and phase 6 is a blowtorch. It's very mild. That's if we go to phase 6. Again, some of this data shows we aren't going to, so it's a very tricky call here. Then if we look at the upper air pattern, what actually happens here, so this is phase 4. And let me call up a marker so you can see it here. Okay, so here's phase, you got an anomaly here, and then you have a ridge here. Now, you don't have a big ridge on the East Coast, so it's kind of not a bad pattern. You're getting some blocking, a little bit of supply of cold air here, but it's not too bad of a pattern in phase 4. It's somewhat warmer than normal, but not super warmer than normal. But phase 5 and 6 is just, look at this. You get a huge negative anomaly. Oops, we'll call it up here. Okay, so you get a big negative anomaly in the Western Canada, and you get a big ridge over the Midwest on the East Coast. And that continues at phase 6. Look at this. Monster ridge here. So this is why phase 5 and 6 are so strongly mild. And this is in February with weak La Nina. All of these are February weak La Nina. See that? Negative ENSO, weak La Nina, February. And then if you go into phase 7, again, now phase 7 is kind of changeable because what happens is the cold air begins to exert itself again and it pushes up against the ridge. So you get one side of the ridge is very warm, and then the other north side of it, you start turning colder, and you get a very strong frontal boundary with a lot of rain or potentially rain, snow, and sleet right along the boundary as the ridge gets pushed back into the Atlantic Ocean. Let's look at our teleconnections on the Pacific side and on the Atlantic side. So we got two of them on the Atlantic, on the Pacific, the EPO, the PNA. The Atlantic is the Arctic Oscillation and the NAO. So let's take a look at this in detail. So here's the Arctic Oscillation, the two on the Atlantic side. The AO, when it is connected to the polar vortex. Let me call this up here. Okay. And when the polar vortex is weak, and comes south, the AO is more likely to be negative. So a negative AO favors below normal temperatures in the eastern U.S. and increased storminess. And a positive AO favors above normal temperatures in the eastern U.S. and less storminess, more towards the western U.S. and the upper plains, the upper Midwest. So you can see the Arctic Oscillation, we are negative, and then what happens is it's gone positive, and it stays positive, a little dip here, neutral, around February 1, and then it still goes positive again. Not great if you like winter weather. This is not good if you like winter weather and snow in the eastern U.S. Here's the NAO, which is usually located in northern Quebec, Labrador, Greenland, Iceland. It may or may not be in the same phase as the AO. Sometimes they're connected, sometimes they're not. A negative NAO favors below normal temperatures in the eastern U.S. and increased storminess, especially if the AO is negative. And again, back here when we're getting the storms, January 18th, 19th, and 20th, we had both were negative here. Now, look what's happened. As you can see, it's gone positive. It's matching the AO pretty close. Look how closely. These are kind of in phase right now. Where a negative NAO favors below normal temperatures, like we mentioned, but the positive NAO favors above normal temperatures in the eastern U.S., below normal in the Midwest and the upper plains. And the East Coast lows, if you get them, track inland. Okay. Now here is the Pacific side. This is the Pacific side. We have two teleconnections here, the EPO and the PNA. So the EPO is Alaska Ridge or Trough, which may or may not be in the same phase as the PNA or the Arctic Oscillation. And the negative EPO favors below normal temperatures in the eastern U.S., increased storminess, especially if the AO is negative. And strongly negatives can lead to Arctic outbreaks. And sure enough, look at the Arctic outbreak. Let me bring this forward so you can see it more. Look at that. You can see how cold the negative has been consistently for January, and we've had a very, very cold January. Then now the forecast to go to neutral for the rest of the month into February. And the PNA pattern, we've been neutral, and then we stay neutral, but generally going negative. And there's the PNA, which is the West Coast ridge or trough, depending on what phase it's in. A negative PNA, which is a trough on the West Coast, favors below normal in the western U.S. and increased storminess in the upper plains, the upper Midwest, and it causes a ridge in the eastern U.S. and generally above normal temperatures. And the PNA pattern brings below normal temperatures in the eastern U.S., and sometimes it can be a dry pattern, sometimes it can be a wet pattern, depends on other features. All right. So for the next couple of days, next several days here, here's what's going on. So we have this huge block which remains here in Alaska, big ridge here. The trough begins, a new trough comes down, but instead of going to the east coast, this one begins to expand towards the northern Rockies because the ridge is now moving towards into the Pacific Ocean. So this drops into here. We get a closed upper low here in California. That's going to bring much needed rain and cooler temperatures for the fires. Meanwhile, the ridge is still there, so we're still getting northerly flows. You have a couple cold fronts coming through at the end of the week, which should keep the temperatures in check into the weekend. It'll start getting a little milder, then we get a reinforcing cold front. So for the next 5 days, it looks pretty dry in the eastern U.S. There's not much going on. And here's the rain for California, where the upper low comes in, and they need that rain very nicely. You can see there, this is from the European, and the rainfall amounts are up to about an inch or so in some places. They could use a lot more, but it's not bad. All right. Now, beyond that, going into the 6 to 10 day, you see the feature here, and it's highlighted in yellow on the upper map here. Let me call up my marker here. Here you go. So there, you see this here? This is a Rex block. The block here on a low underneath it, that's a Rex block pattern. All right, and what it does is it favors the trough being here on the west coast of the Rockies. So the upper low comes eastward, all right, and it begins to weaken. You can see there it is in Texas now by February 1st, right? So the red blocks is here. You have a new anomaly coming down, upper low in the British Columbia, and another one in Newfoundland, Canada. The question is what's going to happen with this southern feature? That's the issue. Now, right now, at this pattern here, this is a mild flow pattern by February 1st. You can only blow this up a little bit. Let me see if I can catch it. Yeah. You can see how mild this pattern is. There's no Arctic cold air coming in here in the eastern U.S. at all. Now, what the European does is, and this is unusual, so here's the front coming through January 31, a reinforcing front, a semi-Arctic high, not severe, but not bad, and it drops down. You can see it goes into Pennsylvania by February 1st. There's your southern low, all right? That's the southern low we talked about here. You can see it developing in Texas, Louisiana, Mississippi, Alabama. Then the European takes the energy in the Pacific Northwest, and it wants to drop it into the Great Lakes and merge with the southern system. And as a result, you get this gargantuan storm here on February 3rd, 4th. That storm, you see that? Nice ridge on the Rockies, trough here, Okay, some positive anomaly in Quebec, Canada, maybe. But this is not a bad pattern for a winter storm on the East Coast. It's not great, but it's not bad. It's a little too far inland. There's not enough blocking downstream, but it's not bad. Okay, and sure enough, here's what the European does, which I'm sure you saw from early this morning. The lows in Louisiana, in South Carolina, right? Yeah, there's your high to the north in Quebec, near Montreal. So you have some frozen precipitation snow in the northwest half of Virginia, Washington, D.C., Baltimore, into Pennsylvania. Then you have ice in southwest Virginia, rain probably in Richmond and Norfolk and Raleigh. You can see that in the Ohio Valley. And then it goes to low passes very close to Richmond or between Richmond and Norfolk. And again, the Shenandoah Valley getting blasted with snow, maybe D.C., definitely Dulles, western Maryland, Pennsylvania, New Jersey. The high is still in place there, so that's not bad. And then the low goes off the coast, and it bombs out when it goes to Delmarva. So the precipitation stays all snow in Philly and New York and New Jersey and Boston, and you get your big northeast snowstorm, the first one of the season, a really big one, if this is correct. Now, this is way, way out in time. This is February 1, all right, February 2. This is way far out there. The other thing is, look at the air coming in behind it. Look at these Arctic air masses coming in behind it like this. I don't get this at all. If we are in phase 4 or 5, this is not going to happen. But again, the European model is showing that we don't get into phase 4. We go into the neutral circle. So if we go neutral circle, then maybe, if we are in the neutral circle on the MJO, we end up getting this storm. That's what you have to hope for. Okay? I'm not ruling it out. I don't think it's likely, but I'm not ruling it out. The other issue here is that the European ensemble, this is the same time frame, February 2nd, doesn't have this at all. There's a monster ridge across the entire eastern half of the country, and the trough is in British Columbia and the Pacific Northwest. This is a mild pattern for early February. That's what this is. The polar vortex is way far to the north. The ridge is now by the Bering Sea. It's a mild pattern. And again, this ridge and the Bering Sea supports the trough in the Pacific Northwest of British Columbia, which in turn supports or teleconnects to the ridge over the eastern U.S. Bada boom, bada bing, bada boom. Right? And now if we go further out in time here, this is now February 5, and you can see the mild pattern. Look where bring this forward. There's your block pattern in Alaska, now in the Bering Sea. It's west of Alaska. It's between eastern Siberia and western Alaska. That's how far out this is. That supports a trough here in the Pacific Northwest and southwest Canada, and that in turn supports a ridge. Ridge, trough, ridge. Bada boom, bada bing, bada boom. Okay? Teleconnections. Very nice. Good way to see how this develops. And then here, now this takes us out way out there to February 8th, and this is the GFS ensemble. It shows the same thing. Right? Same thing. So very good model agreement here. Interestingly enough, through the 11 to 15 day, the temperatures are not that warm in the anomalies. This is the European, the GFS. They're not that warm. You would think they'd be better, a little warmer than this. So I'm not sure I like this idea. Now, this is essentially showing near normal temperatures. Ohio Valley, Great Lakes, Mid-Atlantic, New England, the Upper South, normal temperatures for late January, early February. Okay, maybe. I think this is a little too cool, but maybe. And that's how I see it. So anyway. All right, so that's the video. Hopefully you enjoyed this one. It wasn't as long as the other ones. I wanted to keep it shorter. Again, the teleconnections aren't great here for that storm on February 3rd, as you can see. Specifically on the Atlantic side, you can see both the NAO and the AO are positive. So that's not great. But if we stay in the neutral circle, maybe. We'll see. All right. And then the other point I wanted to make here is when you get around to this, the extended models, the CFS extended beyond this one, actually has it going into phase 7 by February 15th or 16th, and that implies phase 8, 1, and 2 in late February and March, which is what we just finished going through with the colder pattern. So that's why I think late February and March is going to be round 2. So even though we may have a fairly quiet interval coming up here in the first half of February, don't think the winter is over. That's my other important point. I don't agree with that argument at all. I think that's a bogus argument. So I know a lot of weather hobbyists, a lot of weather fans out there. They like to use this, game of reverse psychology. Oh, winter's over. I'm never going to see snow. Of course, they get the snow, and they think that matters. It doesn't. It's a human characteristic that we all have. But no, the universe really doesn't care whether you're depressed about your snowfall or not. It's going to happen when it's going to happen. This is meteorologist DT from Weather Risk. I'll see you over on the Blue Sky Weather Risk page, and then over on the website and the Facebook page.